All right. Good afternoon, all. Wait, give me 1 minute. Yeah. If you got any question that you want to ask, all right, please ask in the YouTube live chat. All right, because when you PM me in my WhatsApp or my Telegram, I don't go and see my phone. All right, so I will not able to answer you. All right. Now, before I start, all right, I want to discuss with you, right, how to do the experiment today. This is the purpose that my stream today lah. Because many of you still not really sure, right? But some of you tell me, Cikgu, I got confident, right? What should I do already? Then very good. Now, come back to very, very easy question first, all right? Today, the thing that I want to discuss is when should we do the experiment from denser to less dense medium, or when should we do the what the one that we should do denser to less dense or less dense to denser medium. When? All right, how? All right, how to differentiate them. Okay, but before we start, I want you to know what is denser, what is less dense first. All right. So I put it into these two ways. All right. Denser to less dense medium. Denser to less dense medium and less dense to denser medium. All right. So we got these two different. So we are going to see which one it is. All right. Now, right, you know the light travel, right? When the light travel, it must be go from the object to your eye. All right. Let's say you got a diver, right? Diving in the under the seawater, right? In the seawater. So don't want diver lah. Diver, I don't know how to draw. Let's say this is a fish, right? Ikan. This ikan, right? This is water, right? This is A. Okay. Now, the fish want to find the food. All right. So first of all, the fish will go to see two different way, right? From the eye here. So normally you will draw to here, right? Eye to here. And then I draw one more normal line, right? No, one more normal line from here. Right? This is a normal line. Now the light will bend away from denser to less dense, right? Okay, denser to less dense. But this is what you always say, right? Denser to less dense. But in fact, this is the food. The fish want to find the food, right? So let's say this is the food, right? Ini food, right? So the light actually is travel from here. You can see the arrow from here, right? The object to the eye, right? So when this one is from, this one is from less than to denser, I shift the position, right? The light is travel from the A to the eye, right? Less than A, right? Water denser, less than to denser. Okay. Now let's say the fish A cannot find, all right? Cannot find the food at here. There is no food here, right? Tak ada makanan. Then the fish will start to swim to other position, right? Swim to other position. Why? Because want to find food, right? So when want to find food here, then the position of this one change, right? Change. So this one we can call it as reflected angle, right? This is incident angle. So the incident angle will be different already, right? Where it is, right? We are going to see. So it will go down from here, maybe. So you'll find that here, whether got food or not, right? The fish will find the food at here. Here got food or not? At the surface of water here, got food or not? So this angle, we are going to call it as critical angle, right? The fish will start to adjust the position, right? So no more this position already. Now this one is here. Now, normally for water or glass, almost 40 something. Water is about 40 at, right? And glass, normally it is 42. When you do the experiment, it cannot more than 42. That's why. Now, here, the fish, find the food here, cannot find the food here. Then the fish should start to move, all right? Tak ada makanan, all right? Move to here, all right? Find, right? Find other way to find the food, all right? So this angle is more than critical angle already. More than critical angle, right? This one more than critical angle. What can happen, right? All right? So it will find, maybe that is a stone, right? Stone blocking here. You got a stone, right? A stone blocking here. And then you'll find that this thing, it is going to happen, right? I use red color. Wait. Right? So this thing, it is going to happen, right? Wait, this stone too big. Here, right? So you'll find it, this one is going to happen, right? And you will find it, this angle, same as this angle. So what is this happen? What is this? This is called total internal reflection, right? That's why we got one peribahasa, all right? The fish find the food at here. That is a udang here, all right? I don't know how to draw udang lah. Udang. Ada udang di sebalik batu. Why? Because total internal refraction happened. You can see ada udang di sebalik batu, right? All right, this is less than to denser. How about denser to less dense? All right, same thing. The thing that I drawn to you before, all right, this is a cup of water, all right. This is a cup of water. Let's say all of here is filled with water, and then that is a coin that I gave you last week. No, not last week, yesterday, right? A coin. So your eye, it is at here. Your eye is at here, and then this coin, all right, will come to here, all right. This is an object, and then this is my normal line. Normal line, I use black color. Normal line, right? You must see the border between the A and the water. The border between the A and water is the normal line that you draw. The normal line you must draw in the border of denser and less than medium, right? Different medium. All right, and then lastly, the light will change direction to here, right? So if normal goes straight, it will not go straight anymore. So it will bend away from normal, right? It will bend away from normal, right? So this one I route it off. This one, it is go toward the normal. Alright, I put my fish head here. Alright, don't confuse you. Right? I put my fish head here. Don't PM me. You PM me, no use. I'm not free right now. I'm not free right now. Alright. Okay? Now this is a foot. Okay. Now this is my foot. So you bend toward the normal. Less than to denser, you bend toward normal. Right? Denser to less dense, it will bend away from normal. Meaning that this light, it will not go straight anymore. Right? This light, it will not go straight. You see, it bend away from normal. Right? That's how we make it. Right? If you understand this concept, now we are going to do sum. Alright, are you okay until here? You need to know whether it is denser to less than or less than to denser. Alright, and if less than to denser, alright, we are going to put here, this is the light come into here, right? Into here, right? The light travel from here to the eye. The light travel from here to the eye. Alright, so this one normally we are going to name it as incident angle. This one, it is called reflected angle, or angle of incidence also can. Angle of refraction also can. This one is called incident angle, and this one is called reflected angle. But during the calculation of N, refractive index, we always use the bigger over smaller one. Right? Sine this one over the sine this one. Sine this one over sine this one during the calculation of refractive index. Not experiment, calculation of refractive index. Alright, I hope you're okay with here. Any question from here? Any question from here before I continue? Any question before? Right, clear? Alright. Right, clear? Alright. Now, of course, now, don't ask me, Cikgu, tomorrow, denser to less than, or less than to denser. Even you ask me tomorrow, light come out or not, I also don't know. I cannot tell you. I don't know. Alright, don't ask me this. Alright, denser to less than or less than to denser, I don't know. Right, but I will do both for you. Yesterday, the one that I discussed is denser to less dense. Why? Because I show you my paper that I use. I copy from the MRSM paper, right? MRSM paper. All right, you see from here, all right, you see from here. Wait, wait, here, MRSM mapper. Yeah, hey, the light travel from where to where? You see the error they drew for you already. Then most of you still not really sure. I find it 50-50, don't know whether it's denser to less than. Tell me, this one, the light travel from denser to less than or less than to denser. See this diagram only. Right? See this diagram only. I never said all my answers, all the question must be come into this way. Right? You tell me this one it is denser to less than, right? MRSM paper 3, right? So it is denser to less dense or less dense to denser. I want to ask you this very easy question. Fiona, what? No. Fiona, you said you want to pass up your work, but you didn't pass up for me. Last night I've been waiting for your answer. Right? Your that one. You didn't do. But later I'll do it lah. I'll do it for you. You know, no need to worry. A lot of you ask me, Cikgu, give me answer. I don't have answer. To be honest, I don't have answer. That's why today I do one for you. We do it together. Nanti pass up Nanti I already give you answer. Then before you pass up. Do bio. Okay. Alright. This one is, you see the light travel from here. You can see the light travel from here. Okay, wait. Let's share this one. You can see the light travel from here. Hey. The arrow for you already. Not I say one, the diagram say one. Right? Oh no. Don't skip your class, alright? This one you can watch the replay. Right? Yesterday the one that I said got some very sensitive thing, so I cannot share. So this one I am not going to talk about the sensitive thing, so I can share. Right? This one normal, boleh. Right? Okay. Now answer is the light travel from denser to less than. Water to the A to your eye. Water to the A to your eye. Right? So I see some of you still not really sure about this one. Right? Purposely or not, I don't know lah. But I can see most of you can get correct, but some still got very small part, not sure. Now come back to how to do it. To be honest, if you want to do this one, you want to do, if the question like this question they don't give you the procedure. You want to do denser to less than or less than to denser, up to you. Okay one, because I and R, it is the same thing, right? I told you I and R yesterday. I explained in detail to you. I and R will be the same thing, just you need to divide one big one small, right? Now if they ask you this way, so you will see it. You see I know it. Actually I have seen this question before, right? If I don't see it, I know, this one is responding by river. Nanti when they ask me about the graph, they should ask me sine I versus sine R. You see? In fact, I already see the question now. Of course I know lah. Right? They'll ask you to plot the graph sine I versus sine R. Impossible they will ask you, plot the graph sine I versus sine R. Then susah lah, right? They will not ask you in that way, right? Because this one is responding variable. You put here near, then this one getting near. You put this one far, then it go further. That's all. Right? This one is depend on this one. Right? This is manipulated. This is responding. Is that okay? right? Okay. Now come back to how to do it. Right, this is the part that you have to understand first. All right, then I will do both for you. Right, and I will give you the result. Now, first of all, how to do. All right, so I want to do let's say denser, no, less dense to denser. I want to do this experiment, right? This is what you have done in school, right? Less than to denser, all right? So normally, all right, when you do this, all right, how to do it? Let's say this is a piece of A4 paper. This is a A4 paper, and then I want you to draw a line at here, right? At the middle of somewhere, straight or not straight, Bangkok sikit tidak apa, no care one, all right? But it can draw it straight lah. And then second thing is I want you to put a cross at here, right? A cross at here to make the normal line. Draw a normal line first, right? No, draw a normal line. Normal line, alright, if you got color, then you use color lah. Easy to see. But no color, it is okay. And it will be dotted line. If you ask me to draw dotted line here, I cannot draw the dotted line here, right? So this is a normal. Right, you should draw a dotted, right? Am I? I draw dotted lah, right? Dotted. But if I draw dotted line, it will so ugly. You use ruler, not like me. Okay? Yeah. Okay. Now, once you get this one done already, then what will you do is you take your protector. You take your protector, and then your protector is here. You put into this way, and then what do you do is you take it to here, not protector, right? You take your protector and measure the angle first, right? Measure the angle first. As I told you yesterday, 10, 20, 30, 40, and label it. Right, 10, we do one by one. You label it first, 10, and then you measure 20, and then 30, 40, all right, up to you, all right? Up to you, right, 10, 20, 30, 40, right, 50, 60. If the procedure asks you from 20, you start from 20. If the procedure asks you from 0, then you start from 0, right? You follow. If the procedure not given, then from less than to denser, up to you. You want 10, 20, 30, 40, 50, okay. 20, 30, 40, 50, okay. So let's say I follow exactly as what you see a lot of video, a lot of people doing this. They start from 20. Why? Because they like. If you start from 10, I can explain to you why they start from 20. But later lah, right? Sorry. They do 40, and then 50, and 60. They do this because of they want it to be fast and easier. Right? 40, 30, 40. My one is not June one. I tell you, I didn't measure. 40, 50, and then 60. You use your protector to measure. Right? After you have done this, then what do you do is you take your glass block and then put it to here. Chun chun. Make sure it is chun chun. And then to make sure it not move away from here, so you make one mark at here, tanda here and tanda here. Right? Make sure at the corner here you make one tanda. If later this one accidentally lali, you still can move it back. You know where to move it back. So this one is the chun chun, the normal line that the light must pass through. So far, any question from here? So far, any question from here? So far, any question from here? No, So now if no, I rub it off this one. All right, I rub it off this one. Now what we do is I want to start from 20. All right. So my laser pen, I shoot to chun this X mark. All right. Now it's supposed to go straight like here, right? Right. But it is not because less than to denser. Less than to denser, then it will move away from normal. You find it, this one is 20. This one is 20. This one maybe, I don't know. Alright, I cannot memorize the figure. But later I show you the experiment that they have done. The result that they have done. Right? So this one probably it is 25. Because it moved away from normal. Sorry. This is less than. This is denser. Oh, sorry. No. It will move toward the normal. I'm sorry. Less than to denser. Oh, it moved toward the normal. I'm sorry. You find it this angle, it is smaller. Alright, I'm sorry. So maybe this one is. Oh, I remember. 14 or 15. Yesterday we have done it. Alright, something like 14 or 15. Alright, 14, 15. Alright, 14. Let's say. So you mark this one. Right, don't measure directly. So what will you do is, now the light travel from here is actually very hard. From what I draw here is very easy for you to see. Oh, very easy to measure. But I want you to just make a sign at here, make a cross at here, or just make a tanda here. Right? Make sure you know where is the position. That's all. And then you make a cross at here or dot here or whatever to make sure you know where it is. Right? If you want to remember, then you make one tanda. Right? Oh, this is for 20. This one is for 20. And then, please, when you do it, make sure you don't tanda from here, very near to the glass block. No. The further it is, the better it is. I repeat one more time. Teacher, what? Of course, you ask me, Cikgu, what is further? What is nearer? Right? I take one from, you see, this is Cikgu Fenso do one, right? So you do 20, right? You do 20, right? Normal line draw, right? 20, So the light will travel to here. Am I right? This is the incident. It will not go straight, right? This is incident. Then it will be reflected, right? It will reflected. It will not go straight. It will toward the normal, right? Now, if you mark it from here, this position, aduh, where? Hello, where? Teacher, of course you ask me another question. Cikgu, tanda here ka, tanda here ka, tanda here ka? I will set tanda at the middle. But where is the middle? Susah lah. Right? Susah. Susah, I tell you susah. Hard to see. Now, how to tanda? The further it is, the better it is. Cikgu, letter further tidak sama. What is mean by not sama? You try to measure. This is angle. Right? So, this one must be chun at the middle one. At the back there, it is thinner and easier. If you can tanda at here, even better. But your FO don't have that long range. Right? So you tanda here will be good. If you can see here well, you tanda here, no problem. Right? Now the anchor here is how much? Same as this anchor. Not the further it is, the anchor will change. No. You can measure it. After you tanda, let's say you tanda here, right? Then after that, you remove this, and then you make this, right? You sambong to the X there, and then what will you do? You measure later this value, right? You measure this value. This value, you measure it later, alright? Don't PM me. You PM me, I cannot move my screen. You PM, you want to ask me in YouTube. I'm doing live right now. You ask me, my screen there, I need to convert my screen, right? Okay. Now, any question from here? 20, when you do 30, the light come into here, right? Light come into here, you'll find it, this one, it is slightly further. You'll find it, it is slightly further. Is that okay for you? Now come back to where that one, alright? So, you mark at here, better. You mark at here, this one look like that just now. How to mark? Susah, alright? Susah, I will tell you just susah. Not cannot, susah. When this one become bigger, right? Let's say I become 30 or 40 or 50. Now, the I become here, then you can mark this. You can mark this position at here. Later you sambong. After you sambong all, your result that you can see is, here got one mark. Not mark. Here got one point at here. Here got one point. Here got one point. Here got one point. And then after that, your result, you got 1, 2, 3, 4, 5. This one is for 20. If you remember, 20. And then this one is for 30. This one is for 40. This one is 50. This one is for 60. More than 50, more than 40 degree, more than 50 degree, okay or not? Okay. Because if you are doing less than to denser, it will always toward normal. Total internal refraction cannot be happen one. You no need to worry about it. If you are doing less than to denser, right? So you will get your result at here. You measure letter, you measure letter, you measure letter. You some of you you are rajin. I know you are rajin, right? Some of you tell me you tell me cikgu, I'm rajin. Okay. I'm hardworking. How? 10 here, 20 here, you mark already 30, 40, 50 here. You measure properly. And then here 10, 20, 30, 40, 50 you also do. Chun 10, 20, 30, 40 50 you measure chun you everything done already, and then half hour. Half hour when you want to do experiment tidak cukup masa, then ring Fiona pass up. Then I haven't do all. Then your teacher will ask you, what are you doing just now? I was drawing the anchor. Then who asked you to draw? Oh, my tutor asked me to draw. I never So you want to draw this, if you think you are very good, very fast, then you do it. But what for? What for? What for? What for you do it? Don't. This one you can measure that later, bah. This one, what is the purpose of doing this? Purpose of doing this is for us to see 10, 20, 30, 40, to see, or it is away from normal or toward normal very clearly. But now you want to get the result, you can measure it later. Is that okay for you? This one, any question from here? Less than to denser, tidak ada, Less than to denser, then I will get the experiment. Alright, reading from less than to denser. Less than to denser, you get this value. When 20, 30, 40, 50, 60, then you got your refracted angle will be smaller. You see it because it's toward normal, toward normal, and then you sign it. You sign the value. Sign the value already. I put it to here, easier for me to plot. Okay, now I want to plot it right now. So they ask you, plot what versus what, the question, all right? They will give you, all right? So now they normally ask you, right? This one, they will also ask you to plot R versus I. R versus I, R versus I. So sine, they will ask you to plot sine R versus sine I. But it can be another way around. Can be. Alright. It can be this way. Alright? It can be this way, or it can be the other way. You see how the question asks you. Alright, then you follow. But normally it is this way lah. Okay, then I do this, I do this. To be honest, I lazy to that one, but I cannot be lazy. Alright, and then please, this 0 also put in. Don't tell me, Cikgu, we all know it is 0. No, I don't want. Right? 10 and 0 and then 0 0.1, 0 0.2. This one actually I have explained to you already. 3, 0 0.4, 0 0.5, 0 0.6, right? Decimal or what? Don't ask me today already. It is over already. 0 0.7, right? So you see the x value here 0 0.7, 0. Sin I, 0 0.7, 0.8, 0.9. You need 0.9. 0.8, 0.9. You do until 0.9, right? Because maximum here it is 0.9. Now you find it. This one is you start from here. This one until 0.6 will be okay. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. 0.6 is enough already lah. Right? Now come back to the question that I asked myself just now. Teacher, why? Huh? They want to start from 20 hall. Alright. Now you see when I plot, huh? Right? When 20, 0.3, 0.24. 0.3, 34 and 24. 0.34. 34 it is at here. Right? 34 and then 24. 34 and then 24. Alright. I don't have ruler. 0.34, 0.35 here. And then 25 here. Okay. The first point it is at here. Right? I marked the first point already. Now, second, I finish. Let me finish, then I answer my question. Alright, first point, and then second point. Alright, 0.5, 0.34, 0.5, 0.5 easy, 0.34, 31, 32, 33, 34 here. Alright, and then 0.64, 0.41, 0.64, 64, 41, 64, 41, 64, 41. Maybe not June lah. Alright, but never mind. You see, I will explain to you again. Level 77, 0.5. 77, 0.5. 0.77, 75, 76, 77, 77, 0.5. 0.5 I double check. Yes, 0.5 77, 0.5. 0.7, 7, 0.5. Yeah. Right. 0.87, 0.57. 0.87, 0.57, 0.85, at 6, at 7, at 5, at 6, at 7, 5, 7. Somewhere here. Right. Five at 7, at 5, at 6, at 7, and 5, 7. 5, 5, 5, 6, 5, 7, somewhere here. Alright, so now I have completely plot all already. Now come back to the question. Just now I said if you start from 10, 20, 30, 40, and then your value will be somewhere here 1, 2, and then 3 and 4. If you start from 5, 10, you will get this, the graph here. That's why they start from 20 lah. Your graph will look bigger. You understand what I'm saying here? If not, you start from you want to start, if they don't give you procedure, they don't give you the value that you want to plot, you want to do the experiment, you do, oh, Cikgu, I do 5, 10, 15, 20, your value will be here later. When your value getting here, then what will you get? you will get your graph not valid or too small. Have to, yesterday I told you your graph at least more than half of your piece of paper there. Your appearance of the graph must be less, more than half. Okay, now I want to do the best fit already right now. Right now, any question from here? I have plotted it already. Unit I told you yesterday. I don't want to tell you already. Right, you know, you will know it. Any question from here? No, no, then you will, it always go through zero, so you start from zero, it will be okay, right? Because sine zero, error must be zero, right? So now I find here, I find the best fit. Use your ruler to find the best fit. What is best fit? I told you yesterday already, right? So this is called best fit, where you see I got 2 points at the top, 2 points at the bottom, right? 2 points at the top, 2 points at the bottom, and just go through 1 point only, but it is balanced. Cantik. This is cantik. This is very nice graph. But if some of you drawing this like that, wait, like that, cikgu, go to 2. This is very, very bad graph. Okay, I tell you already why. Right, this is a good graph. All right, now this is how you do it. Now you can find your gradient there. Now the second thing is, what I want to say just now. I suddenly forgot what I want to say. I want to. Oh yeah. Come back to here. Cikgu, this is a common question. Yesterday night, a lot of you PM me. Cikgu, the value that I get, what if not the same as this? Now I want to do this. Teacher, what is not the same as this? Okay. Now, what do you think that you will get if it is not 14? If it is, let's say this is 20, your I 20, when you do the experiment, I is 20, I is 20, 20. What do you get if it is not 14? Let's say the glass all use 1.5, in refractive index is 1.5. What if it is not 14? Mean it is agak-agak 15 no, right? 15 no? Is that okay? 15 or 14 or 15, right? Or do you think you will get 75? If 75 mean you accidentally write 15, you look like 17. What is this? This is called error. This is called random error. When you got random error, I cannot help you. Nobody can help you one. Right? You will see your graph later. You see your graph, first point it is here, cikgu. Everything just nice, but got 1 point like that, then you plot the graph like that. So you go and check what's wrong with it. You see wrong, or you mark wrong, or you measure wrong, or you calculate wrong. Okay? Now, the second thing is, if cikgu, this one 15 or not same as yours, okay, never mind. We go and see, right? We go and see, We go and see with calculator. Sine 15. Sine 15 how much? Sine 15. This is incident is 20, is 20, sine is 0.34, This one sine 15, 0.256, 0.256, right? 259. 0.26, okay? I put 2 decimal, 0.26, okay? Alright, how many decimal? Yes, I explained to you yesterday. Alright, no, today no time for that. Right? So 0.26, meaning that your graph will be just slightly 0.26, 0.2. Your R is 0.26, here is 24, 25, 26, slightly here. Will it very far away? not very. I would just say not very. Sikit-sikit ada lah. If you said very far away, no. That's what caused this. This is the thing that I told you, right? Just now I told you when you do the experiment, the light come from here. Let's say the first angle is 20, the light come into here, and then the light memang like that one. You cannot get a very good result one. So when you tanda here 26 cikgu, 26 because hard to see. So if you can get a good result, you will tanda here. Then you will not get this problem a lot. You understand what am I saying here? But 14 to 15 will be acceptable. I mean, the value as long as not 65 ka, 35 so far away. Satu petak, dua petak, different, okay one lah. You understand what I want to give you? You understand what I want to tell you? So you will get very close result. Right? Memang like that. You will not far away. Okay? This value, right? You can measure, right? So you will agak a bit different. Agak. Now some of you PM me yesterday. Cikgu, can I go and memorize? I am a tutor, I am a teacher. I wish you can get a good result. But I really hope that you learn and understand what is the purpose of doing this experiment, to understand it. To test you, right? Next time, if you are a light engineer, then people ask you, oh, I memorized 14, 20, what for? You don't understand how it is work. Okay. So when you got this one already, so everything just plot, you can calculate. Now, when you calculate the gradient here, it cannot more than 1. Why? Because it is, right? We calculate the gradient from here. M is, when you do this, when you want to calculate the gradient, so I want you to do this. You find a very good spot here and then draw here. Now, teacher, it is not under the point. Not necessarily go into the point, right? And then, as long as it is in the line. Alright? So, I'm not drawing well. But anyhow, you... no, I cannot say it, not drawing well. Alright, here. Alright, after that, I want you to draw a 90 degree at here. I want you to draw a 90 degree at here. Make sure you know, they know you are drawing 90 degree. Make sure you do it. Your small test, your school test, I never ask you to do. But in SPM, I want you to do. You can calculate the gradient here or not? Can. They don't ask me, can. It will not affect anything. This one use dotted point, dotted line or straight line, up to you. If straight line, solid line, make sure it is lighter. This is the graph that they ask you to draw. The straight line is mean it is under your part of your answer. So you use dotted line, it will be the best. If you don't want to use dotted line, you feel dotted line is very hard, then you use you use the very light straight line, light color, light. Draw it lighter lah. Don't draw it so thick. Okay. Now I want you to draw the biggest triangle when you calculate the gradient. Right? The gradient will be here. Will be now this point. You can put in the point. Right? This point will be 0.9 and then comma 0.6. Here 0.9. Here is 0.59, about 0.6. I round off to 0.6. Okay. So now how to find the gradient? All right. The gradient will be, I do it here, not enough stress. I do it here. 0.9 minus 0.0. Make sure it is 2 decimal. 0.90. I'm sorry. 0.60. Hey, I do it here lah. Here so annoying. I do it here. I supposed to do it in the question. Alright. So over. Now here it is. It's 0.6 minus 0. I'm sorry. 0.60 minus, what am I doing? Alright, over 0.90 minus 0.00. Okay, this is what you have. 0.6 divided by 0.9, what would I get? 0.6. 0.6 divided by 0.9. What will I get? I'll get 0.0. 0.6 divided by 0.9. I'll get 0.67. So you should know your answer is 0.67. Okay? You should know. Yesterday we also do it before. Right? Equal to 0.0. 0.67, no? Let me double check. Yeah, 0.67. Right? Now, this is the first part that they ask you. Any question from here? Now, what is the gradient of the graph? It is not refractive index. It's terbalik, salingan of the refractive index. So, the refractive index will be you salingan it back, inverse it back, inverse of the you get 1.5. Do you understand it? Yesterday we have done it, right? So this is the first part that I want to do, right? Any question from here? Any question from here? Before I continue with this one, yeah, this one yesterday we had done it, but anyhow I do it again for you. Huh? Any question from here? No, huh? Okay. You know what is the answer? Is it this one? 0.067? If you inverse it back, then it will be 1.5. Right? If you sir, my teacher say the original coordinate not accepted. Can clarify? I don't understand you. Why cannot? I don't understand the question. Can you elaborate your question? What is not accepted? What is not accepted? What is not accepted? Why the origin is not accepted? Cannot go through? Your teacher said cannot go through this, or what? Is this about this question? Must get more point. It counts from 20 degree. I explained to you why just now already. If not, not 0 degree. Yeah. If you start from 0, 10, 20, 30, 40, 50, your graph will be very small. The reason is, I told you just now, you start from 10, 20, 30, 40, 50, your graph probably 50 until here only, quite small. You understand what am I saying here? So it starts from 20, 30, 40, 50, up to you. If the procedure give you 20, then you start from 20. If the procedure give you 10, then if you want to start from 10 also. If the procedure give you 10, 20, 30, 40, 50, you follow. You just follow. If the question not giving you the procedure, up to you. Free. What is that called? You can do it as what you like. You want to start 20, you 20. You understand what I'm saying here? They ask you to do it this way, got reason one. But they don't tell you the reason. Because tell you the reason so susah lah. Later susah lah. You just follow. No need to think so much. And then this is not the time for me to tell you why you should plot it this way. You must follow this way. Okay? Must follow. Now, I start from here. Alright, I do this one. So I want to do the experiment of denser to less dense. No question from here, then I will start to do this already. I do both for you. Now, come back to the question. I don't want to that one. Right? Come back to the question. This one is exactly the same. You draw one straight line. Oh, sorry. This is a piece of A4 paper. And then you draw one straight line at here. Right? Now, make sure you make a cross at here. Letter easy for you to find where it is. Now, place your glass block at here. Tidak cantik lah. Iya. On draw cantik-cantik sikit. Place your glass block at here. Okay? And then start to do the experiment. Exactly the same. But this one got one problem. Normally, the school teacher, they don't do it this way. Why? Because this one susah. Because if I start from 20, I want to ask you, alright? You see, this one is the light travel from denser to less dense. Now, of course, yesterday still got some of you ask me, Cikgu, I don't really understand, alright? The part that you explained here, right here. Now, why the light is not bending here? Because the incident angle is 0. Why? When the light come in here, this is tangent, this is... sorry. I'm not drawing well. Right? When the light entering here, right? So I draw one tangent here. So the light entering here, so it is always enter at 0 degree. Always enter at 0 degree. So it will not bend here. Not like this. Hey, this one go away. This one go away. Not like this. The light come in here. It will bend. Why? It will bend. It will bend. Why? Because it is not 0 degree. Now, if the light go in 0 degree, it will bend to left or right. No, it will go straight. So, when round surface, is always go in with 0 degree. Alright? But this part is not the one that you should concern about. It is the point at here. That is the point that you need to concern about. So, now, the light entering here, then, it go out already. It enter less than to denser, I know, but 0 degree, it will not bend anywhere. Right? So, now this one, it will bend where? Right? Toward or away? Toward or away? Toward or away? Answer me. Toward or away from normal? Toward or away? Answer me. Toward or away? Toward or away? Away, huh? Alright, away, Okay. Away, Now, I suggest you one reading. Now, we start from 20, okay? Any one of you like it? 20? 20, okay. Now, 20, Then we do 30, the next one. Right? If you do 20 and then 25 and then 30, 35, susah lah, because they are very, very close. When you plot, they are very near. So when 20, then next one should be 30 lor. 30, what happened? You come to here. Then you use 40 lor. The third value, 40 lor. Right, 40, Then it come to here. Then you use 50, The fourth value, you use 40, Then what happened? Now, I want to ask you, can I start with 20? Can I start with 20? Can I start with 20? Answer is can, but your value have to be very close to each other. 20, 25, 30, 35, 40. Once you plot the graph, you will get this value. Your graph. I write off this. When you plot the graph, you will get your graph like that. Here. And then here. I'm not drawing well. I chincai draw. You'll get your value here. 20. And then 25. And then 30. 35. And then 40. Like that. Do you think it is a good graph later when you plot it? No. No, right? Alright? No, no, then teacher, we start with 10, no? 10, okay, 10, 10, Alright, if you start with 10, okay, never mind. Let's say we go for 10. June 10. Then second value, what do you want to put? 20, 10, 20, 30, 40, 50. Still more than critical angle. Apa macam? I ask you one question. Shukran. I don't know how to pronounce your name. I'm sorry if I pronounce it wrong. Shukran. Do you think what is the value the best? The first value that we should put? And I don't want it to be near. What is the best? 1. First value we put 1. And then 1, 2, 3, 4, 5. Do ma. Do ma. 15. Then second value. You put 15 and then second value. 15 and then 15 and then 30 and then 45 and then more than critical angle. More than critical angle, the whole thing is fail. That's why this experiment harder to do. You got 3 value. 0. To get 5 points. 0, 10, 0, 10, 20, 30, 40. Right? I got 5 points. 0. Shukran, you see? 0, 10, 20, 30, 40. You got 5 points. June, 5 points. You see here? 5 point. 1, 2, 3, 4, 5. I plot for you already. You know why I start from 0? You know why I start from 0? I was forced to start from 0. If I don't want to start from 0, I don't want to start from 0 also. If you don't want to start from 0, mean you got 2 ways to do it. Plot your value very close. 0. You don't want 10, 15, 20, 25, 30. Or 15, 20, 25, 30, 40. Which is, I don't think it will be very good for you. Because the value will be very near, hard to plot, hard to see. Actually, this one is the one that I explained to you yesterday, but I got not enough time if I want to explain that detail for you. I was forced to start from 0. Okay? No, I don't. Not. If I don't want to start from 0, mean susah. And then I told you why this question susah to do. Most of teachers, they don't want to do. Right? Because when you do this easily, when you do this question, got one reason is this. This one, wait, this one, when we do this, when we do this, you see, there will be some light go here. Even teacher haven't total internal reflection, I know. You should not ask me this question. You should not ask me this question, you know why? You ask me this question, then I understand that you don't understand. I understand that you don't understand. Alright, Shukran. I explain to you one more time. You see, see, you see, this is denser, this is less than. The light travel from A to the glass. Alright, then what will happen? You answer me. You bend toward or away? You answer me first. Shukran. Toward or away? Here, toward or away? Toward or away? Toward or away? Toward or? Alright. So, 10 toward. I start from 20, still toward. Alright. Toward mean this one 20, this one less than 20. So, when I increase this value, it's still lesser. No matter how big the incident angle, it still will not critical. Total internal reflection cannot happen. Am I right? I do like that. At T, also, it will bend toward the normal. How can total internal reflection happen? Because it's always toward. Because the light travel from less than to denser. Total internal reflection, the syarat happen. Must be denser to less dense. Denser to less dense. Away. If you more than this, what happened? You more than this, then like that. Your question is only, you say only denser to less than, right? Why? Because it happened to be like that. Do you get what I mean here? This one will never happen. Never happen. Right? Whatever angle that you like just now, you want to do this one you want to do 20, 40, 60, 80, up to you. 10, 20, 30, 40, 50, 60, 70, 80, up to you. You want 85 also can, up to you. This one tidak boleh, this one susah. More than this, then you cannot plot the value. Yeah. Yes. Denser to less dense, right? Because your first question is asking me, only happen to denser to less dense, right? Yes. You cannot. If you more than it, total internal refraction happen. Do you get what I mean here right now? Now, and then the second thing that we always face is the thing that we always facing the thing that we're always facing is now you see this light come out kacau kacau. Teacher, this one total internal reflection, no, not yet. This one cikgu, this one total internal, not yet. This is cikgu, this one got total internal reflection, not yet. But you see some light kacau kacau at here. You see, if the angle is small enough, then you will not see. You will not see it. So this question so annoying. One thing is here, but who know it can come up in this way. That's why yesterday I do this question for you. I do this question for you to make a spare. Let's say the question asks you to do it this way. Then you know what should you do. Why the textbook sign I told you I and R it is the same. This one I explained many times already. I don't feel like I want to explain this one already. Because okay, I explain one more time. Now you answer me. This is a glass. This is the thing. Okay. Now I want to ask you, is this a incident angle? Let's say 30. Is this an incident angle? You went toward, right? How the question asks whether we need to tensor to lesson to tensor. Alright, come back to your Fiona question later. One by one. What is this angle? Let's say 20. Let's say this is called incident, right? This one is called reflected, right? Am I right? Am I right? Anything wrong from here? Nothing wrong, Now, then the light will be travel away from normal, right? Here it will travel away from normal, Away from normal, Now come back to mathematics form 2, right? Zigzag, zig, zigzag, zig, right? What is this angle? $20, right? What is this angle? I told you it is parallel. These two is parallel. This angle is 30. Now I want to ask you, is this a I or R? You answer me. The light come in here, and then go out here. Is this a I or R? I R Now, teacher, you said Snell said the N is equal to sine I over sine R. Isn't it equals to sine 20 over sine 30? Then salah lah. Small over big. N cannot less than 1. Now who care who is I, who is R? No one care. Because I is R, R is I. You get what I told you? This one I explained many times. I and R, it is the same thing, right? The light can go in this way, mean the light can go in this way. This is I, then this is R. Can. This is I, then this is R. This is I, then this is R. How to find the N? Always use big number over small number. That's all. Now, which one is I, which one is R? I don't care. No one care. Now I ask you, you don't see this one, you don't see this one, I cut it. Now tell me, this is I or R? You tell me I. Why not you say this one I, this one R? Same. I and R is the same thing, just an angle only. You get what I told you? I is R, R is I. Okay. Am I making you clear? Now come back to this. Wait. Come back to this. Alright. Now, because of Snell, right? Because of Snell. Right? Snell. You see, if I ask you to plot, you see, this one, if I ask you to plot, you will get gradient less than 1. Do you think nice? Do you think nice? This is the one that you do in school. Now, shouldn't I ask you to plot sine I over sine R? Later you get your gradient more than 1. You understand what am I saying here? But the problem is, if you ask it this way, it is the ballet from the experiment. I'll give you one very easy example. I am about to give you one. Give me 1 minute. I can find. Wait. Let me explain to you in another way. This way. Okay. This is Hooke's law. Hooke's law say what? Force is directly proportional to extension of the spring. Right? I ask you, this is the original length of the spring. You hang something on it. What is your manipulated? The force. How much force is applied on it? X. Responding is this one. I just made just now because many of you asked me. I want to take this one as your example. When Hooke said this one, gradient is k. Yes, he said that. But when we do experiment, you hang something on it, your weight increase, your weight increase, your weight increase. This is manipulated. Manipulated. We always put it here. Responding, or you put 2 kg, extend 1 cm. You put 3 kg, expand 5 cm. You put 7 kg, extend how many cm? Like that. Now, if you do it this way, not to say cannot, you put 1 kg, and then you plot graph like that. You plot graph like that. 3 kg like that. Oh, extend 4 cm. Aduma, who teach you one? Alright. Cikgu, who told me one? Yeah lah, I know lah. But anyhow, this one wrong or not, I never said wrong. But logically, just now in the group, I've got some of you ask me, Cikgu, what about it ask in sine I over sine R? Logically, they will not ask you that way lah. Not logic to ask you, hey, plot F versus X. Ayo, susah lah. I know you want to find the K. I know. The K will be cantik. But logically, we are going to do it this way. Get it? Where am I? This one I don't really feel like want to do. Okay, I show you the one that this one is the one that I plot, right? Because of I don't want to spend too long time here. You want to rest. I show you what I have plot yesterday. The data, right? Wait. Let me see result. Mana this is what I plot, right? You see? Yeah, okay. I do it here. 0, and then it is 0. Alright, 1 point. And then here 0.1724. 0.17 here, and then 24 here. You plot 0.34, and then you got this 0.34 here, and then I got this 0. There, I get this 0. Here, I get this. So I get my gradient. Gradient is here. This value 1.0567, 1.07 minus 0 over 0.7 minus 0. Okay, not enough space, so I put it 0.0. Actually, I should write 0.00. This one is 0.70, right? Write properly, 2 decimal, 2 decimal. Then I get 1.53. 1.07 divided by 0.7. 1.07. 1.07 divided by 0.7. Then I will get 1.53. 1.52 at 1.53. So your answer will be 1.5 something. So if you do this, you will get back to the same thing if you do my question. So that's the difference of when you do the graph like this or like that, right? This one your school teacher. This one yesterday if you join, right? I gave you, right? You plot on your own, you will get it. Okay, come back to Fiona, right? You ask me what the question, Cikgu, Fiona, your teacher, how the question asks whether we need tensor to lesson. Okay, see here one more time. See properly for one more time. The light travel from what to what? Answer me. The light travel from where to where? See properly and answer me. See properly. This is MRSM. See properly and answer me. Okay? You answer me already, huh? Alright? Water to the air, the arrow show you, you see the arrow, huh? Yesterday I do in the Telegram group also, and then second thing is they also ask you, alright, here, this is the first thing, how do you know, they want to plot what, second thing, alright, this is your manipulated, this is your responding, right? So they will ask you to plot sine R versus sine I. Logically, they have to ask you in this way. So your y-axis will be sine R, here will be sine I. You see? You see one more time. I cross my eye. I know what they want to ask. Right? Use the graph. Plot sine R versus sine I. Sine R versus sine I. They have to ask me into this way. But anyhow, they can ask it in the another way. Can, but not so logic like what I told you. Not so logic lah. You ask me in this way. Your manipulated and responding terbalik direction lah. You understand what I told you just now? I use this example to tell you. Yeah, I never said wrong, but I will tell you, you are not a very good question asker. Alright, you ask like that, then you are killing me, you know. You should not ask me that way. You ask me that way mean show you your question no standard. Are you clear? What should you do? What should you do? Any questions from here? Any question from here? Now this one is I, this one is R, can or not? Can. You will get your gradient. Repeat and repeat. Oh, repeat and repeat. You get your gradient 0.67. That's all. You get this 0.67. Like what I have done for you here. Now that's why I don't like to do. I don't like to do this. Your gradient 0.6. They later they cannot. Very susah one to ask you question. No, ask you what question? Yeah lah. Then they ask you what is the gradient represent? Then most of you will write refractive index. That's why when my paper 3 here, I do both for you. Yeah, I do both for you. Right? Yeah. First one, First one, sine R versus sine I do it, and then second one, I ask you, plot this graph. Yesterday, not enough time. I said, you do sine I over sine R, plot sine I over sine R. Sine I is here. Sine I is here. For this case, sine I manipulated. You put here. I do for you. And then sine R is here. Some of you do it, right? Like, who do it, Okay, I'll show you. You're not it. Some of you do it. I like it. You see, you plot both. And you plot both. Yeah. This one is sine I, sine R versus sine I. You get this, right? And then you plot this one for me. You plot this one for me. It is sine I of sine R. What will you get? Your gradient 0.67. 0.66, 0.67. What is the gradient of the graph represent? 1 over n. This is what I told you yesterday. Right? If the question asked into this way. Now, of course, you will come back to one question that's really killing me. Gradient, how much is gradient? You see, you find this gradient, you find 1.52. Right? Then what does the gradient represent? Teacher, this is sine R, this is sine I, and then n is equal to Then isn't it this one different? No, I said no. I and R don't see formula. Use big over small. If more than one, it is N. Get what I mean here? This I and R just a name only. You get what I want to tell you? Don't tell me, Cikgu, hey, this is more than one, or this is sine I, N is equal to sine I over sine R. Then you are kidding me. Huh? Your N is more than one, you said refractive index. Your N is less than one, you said, oh no, that is 1 over the refractive index. That's why I do 2 set of questions for you. And then, see, one more time, if you do this kind of question here, your N is this one, this is wrong, so your answer should be 1 over N. If you answer me, hence find the refractive index in the question, hence mean you have to use the answer of here and here. If you don't use, you don't write 1 over N, you don't write I don't see 1 over N. I know you tahu, you go and find the gradient and then terbalik it, I know, but you will not get the mark. Hence mean you have to use the answer. They want to see whether you understand what is this one. Meaning that you have to use 1 over N is equal to my gradient. This one go up, this one go down. N is equal to 1.51. That's how you get it. You know, I set your name as student 1, student 2 because I want to use it. If not, I'll set your name as your that one. That's why I purposely go and change it yesterday. Any question from here? Hey, not this one. This one. Any question from here? This one I didn't do lah. Yesterday we have done it already. You have done it so many times already. You just plot. And then if no, I go to the very last part. Any question from here? Alright? No, before I go to very last part, alright, of course you ask me this one. Cikgu, if this question asked in this way, then what should they ask? This is I and R, huh? No, not enough point, not enough mark, not enough mark, not enough mark to ask observation. Observation will be asked, it is called inference and hypothesis. What is the observation? What's the observation? This is not biology, not chemistry. Observation is your tabulation of the data, your graph. Your how to analyze your data. Physics we talk about how to analyze. Must be quantitative. What is mean by quantitative? I tell you, let's say, okay, I don't want to talk about this one, okay, I simply talk about the manipulated responding. Okay, here, spring, let's say, spring, same number, this is 100 ton, the 100 ton, right, yeah, this is north, this is south, I drop it down. This one very high, north, south. Drop it down, right? Boop, boop. Okay. What is the manipulated variable here? Answer me. I'm answering your question. Later I'll go last part of how to adjust the data if you don't know how to do. Last one. What is the manipulated variable here? $100 $100. Manipulated variable. What is a manipulated variable? Yeah. I simply choose one. I simply take one. What is the manipulated variable here? This is a magnet. I drop into the solenoid 100 turns. This one 100 turns. I drop here. Answer is height. Yes. Best one is velocity. Why? I tell you. But in the experiment, what you said is height. Yes. Both are okay. Velocity V. Okay. Responding variable. Responding variable. Mean. You put one bulb at here. This one brighter. This one dim. Okay. Brightness of the bulb. Brightness salah. Why? How do you measure brightness? Letter this one from 5 not from 3 From 3 you answer this way. When the height 2 meter, 3 meter, 4 meter, 5 meter, dim. A bit bright, very bright, super bright, like that Then how you plot graph? Dim, bright. So this one is not brightness. This is you put 1 ammeter at here. Reading of ammeter or induced current. This one baru form 5 punya standard. Ini you mau bikin ini, you balik pergi form 3. Form 3 ada slot for you. You ask your teacher, I want to join back form 3. Quantitative, how to measure? This one how to measure? You tell me how to measure brightness. Bright, very bright, super bright, extremely bright. Like that No. Must be quantitative. Why height can? Because height is easy to do. If you want velocity, you have to do tie this one, ticket tape, calculate the velocity, or use stroboscope, turn it to see how fast it is turned. Susah lah, don't want velocity lah. But teacher, you said the lens said or Faraday said it cut faster of velocity, rate of the change of the magnetic flux cut. Yes, the thing is velocity, but this height represent velocity. Understand it? They cannot ask you observation like that one. Must be ask you quantitative one. Manipulated and responding. Observe what happened. Bright, dim, super bright, extremely bright. No lah. No. From 3 baru ada. Get it? I'll come back. I don't want to. This one is not related to our exam. I actually don't want. Right? It will not ask you one. You ask me also no use. Right? For your understanding. Okay. Alright. Last one is. I want to open a file. Give me 1 minute. Okay. I know what I should get. Yep. Okay. Now this is the one that I have done. Right. Perfect value from the calculation. Okay. Now you have to do it on your own. You have to do your preparation on your own. And I forgot to do the other one. Not enough time. I'm too busy. Right. So now n is equal to sine I over sine r. Right. So now, okay, now yesterday night got student PM me, Cikgu, can you do acrylic 1.49 for me? This one simple calculation you go and do on your own. Okay, now I do this one is right less than to denser. You see 0 to 40, you know I want to denser to less than, to less than denser to less than right, 0 to 0, right, 0 to 14. How do I get it? How do I get this one? Teacher, this one is experiment. Just now I gave you one experiment one, but this one is theoretically value. You see, there is some difference there, right? This one you cannot get chun value one. Alright, so now theoretical value is, how do I get it? I show you how do I get it. N is 1.5. Let's say sin I, this is big, this is small. Big one put at the top, 10. Right? This is, sorry, this is small, this is bigger. So I want to find the bigger value. Sin this one, I don't know. Right? Sin R, I don't know. Divide by sin 10. If 1.50, we calculate 1.50 first, right? Easier. Right? I all based on 1.5 to calculate. Alright. So 1.5 times sin 10. Right? 1.5 times sin 10 is equals to, and then this is sin R. But I want to find R. I shift sin answer. I get 15.01. You cannot read 15.09. Maybe you can read 15. But the experiment I get is 14. 14. So this one. If you are using acrylic ball, cikgu acrylic you go find density or acrylic if you want, right? How? Sorry, I write this number in. I do sorry. I do 1 or 2 for you first. Right? This is 15. Let's say I want to find this angle. This one I don't know. I don't know, meaning that when I do this experiment, it is denser to less than. Denser to less than is, I do it this way. I want to see how far it is. I know this value will be bigger than 30. When my incident 30, it will bend away from normal. I want to find this, right? So I know the n is 1.5. Sin I over sin 30. So what do you have is 1.5 times, this one go up, time sin 30 equal, right? It is sin R. And then I want to find R. I shift sin answer. 48.6. 48.6 is your answer. 48.6, 48 also can. 49, chincai lah. You want 49, then 49. Like that. That's how I get it. Perfect value. R is 49, like that. Actually, you cannot read half. Why? I told you yesterday. Now, do you understand how is this one I calculate? Do you understand how do I calculate this one? If your n is if you want to put your n as 1 acrylic, teacher acrylic 1.49, then go ahead your sin you want to find which one? This one, don't know sin R, and then sin 20. Okay, go up, right? R is 1.49. You go and press it. 1.49 times sin 20, and then shift sign. Answer 30.6. 31 lah. You put 31 like that Get it? Do you understand what I want to tell you here? You want to do on your own. If you know how to use Excel, you go and use Excel. It will be very fast, right? But I am not very good in Excel lah. How to do Excel? I don't waste your time. This one easy thing. You don't spend too long time into here. Spend time to understand how to do it to get them up. And then one more okay. You see here before is now. You see, this is the video that I spend money to do promotion lah. Mean I do Google Advert lah. If you can, you help me in comment. If you more than 50 comment or more than 100 likes, then I'll do paper 2 for you. I'll do paper 2 for you. But next week I'm start to become busy. Not next week, tomorrow. because I'm preparing for, you know lah, I'm doing my February, my class start already, and then I wish I can help you more, really. If can, I will help you. I really want to help you, right? But you help me, I help you, you help me lah. You help me to promote. If I got no student, then I lost my job. Then I cannot help you anymore, right? You help me if you got brother or sister, or you got your friend want to join tuition, you can promote to them. Mr. Lee, not bad. Not bad. At least know how to answer sikit-sikit lah. Not very good lah. But at least he know how to answer. Right? Right? And then second thing is if this video, not this video, the one that I'm doing right now, the thing that I sent in the link, comment more than 100. You see, more than 50 comments, then I'll do one more free for you. I put in the Telegram group to inform you. Right? If something that is sensitive, then I will not, like yesterday, something like sensitive. I talk about marking scheme, all these, not suitable for me to open to public. Something like this one, general one, question one, ole, I can. Any other question that you want to ask me? Any other question that you want to ask me before I end the class? Help me to like and comment, if enough 50 comment, I will do one more for you. I'll find time, either Saturday or Sunday. Weekday I'm not free. Weekday I'm not free, I'm doing tuition. Okay? If no, then I wish you very, very good luck. And then give yourself a big clap. Hopefully all of you will get very good result in SPM. And paper 2, you need to spend some time. My advice is don't spend too long time reading book already. Go do some question. Go do some practice. The question keep on coming the same one. Objective, especially objective, is will keep on repeating. Don't do the hard one. No point for you to do hard one, right? No, right? Do some easier thing, right? To build your confidence. And then I told you, right? Objective, 23 mark. If you follow the step that I told you, 23 to 27 mark, you can get A already. Right? If this question, you can get 14 mark. Alright, I wish you very good luck. Alright, I'll see you soon. Alright, see you. Alright, all the best. All the best. Bye bye.